Okay, so again, we're going to have our books open to page 355. Again, if you do not have a book, the sub does have copies for you. I will be checking this for completion if I have you on Monday, or if I do not see you Monday. Remember that Monday is a gold day, Tuesday is a black day, because we do not have school next Friday. So I'll be checking this for completion. The sub does have completed notes if you have any questions. Again, on your desk, you should have pencil, a bucket of highlighters and colored pencils, and a bag of algebra tiles that the sub will be bringing around to you. The colored pencils and algebra tiles are not for this lesson. They are for the second lesson. So please do not open them until you need them in your book. So again, guys, on page 355, and our bell ringer this morning is kind of a different type of question. It says a town is organizing a children's parade in which participants may walk or ride any type of non-motorized vehicle. Parade participants will line up in the parade according to the number of wheels on their vehicles. Students should consider bicycles, tricycles, unicycles, and pedestrians and describe the order in which the pedestrians are lined up. So again, as we're looking at this, we're thinking of the types of vehicles that they would be riding or if they're just walking. If we take a look here, it says according to the number of wheels on their vehicles. It does not say least to greatest or greatest to least, so we can assume one or the other depending on what we want to use. So again, if we're lining these up based on the numbers of wheels, we could put the tricycles first, then the bicycles, the unicycles, and pedestrians can be going last to make sure that they are not being run over. So again, we're going to start here on page 355 today, and most of this lesson is going to be looking at and introducing new terms of vocabulary. So we're going to learn words to identify parts of a polynomial, which polynomial is a new word, and be able to identify the degree of a polynomial. And again, degree is a new word because it does not, in this case, mean how hot or cold a polynomial is. It has a completely different meaning in this context. So before we look at this, we're going to read the Connect to Science. So solar panels, also known as photovoltaic panels, are made of semiconductor materials. A panel has both positive and negative layers of semiconductor material, and when sunlight hits the semiconductor, electrons travel across the intersection of the two different layers of material, creating an electric current. This is a very good question to go ask your science teachers about. I'm sure they'd be very happy to explain this to you. So again, solar panel device that collects and converts solar energy into electricity or heat. The solar panel consists of interconnected solar cells, and the panels have differing numbers of solar cells and can come in square or rectangular shapes. Number 1 is a very simple diagram, and it asks how many solar cells are in the panel below. Now, we could go through and just count every single one, but we're in algebra, so let's use a little higher level thinking. I see 1, 2, 3, 4 across, and 1, 2, 3, 4 going down. So this means I have a solar panel that has 4 rows by 4 columns, or a total of 16 solar cells. So again, we didn't just count them, we're going to go through and actually use area to find the total number of solar cells. So number 2, if a solar panel has 4 rows, as the picture does, but can be extended to have an unknown number of cells, x, write an expression to give the number of solar cells that could be in the panel. So again, an expression does not have an equal sign, and we're looking for what it could have. We don't know. Only thing that we know is that there are 1, 2, 3, and 4 cells. Or sorry, 4 rows. And again, we don't know how many columns this could make up. But the problem does give us a variable to use, x. So just like above, if I know I have 4 rows, I have x number of columns, an expression that I could write here is going to be 4x. That represents an area of any number of columns. Number 3 kind of extends that idea and asks us to write an expression that would give the total number of cells for a solar panel having x rows and x columns. So like above, I don't know how many columns I'm going to have, x, but now I also don't know how many rows I'm going to have. We're still using the same idea, the number of rows times the number of columns to give us x squared. Essentially, this is asking us to find area of a solar panel, and each cell is a square unit. So if we think about any square is x by x, and we can always find the area of a square by squaring the sides. Okay, 4 takes it a little bit further, asks if there are 5 panels. Write, again, an expression to represent the total number of cells. Well, that one's pretty simple. Times 5. Now again here, guys, introducing the first vocab term. All of these are, again, terms. I was trying not to use that word before we got to it, but it's kind of hard. But a term is a number, variable, or the product of a number and or variables. So each one of these numbers that we have gotten so far, again from number 1 we had 16, 4x, x squared, and 5x squared are all terms. I've used this throughout the year. I know we haven't defined it until now, but I've used this vocab term throughout the year because I think I introduced it to you at the very beginning, talking about how many terms are in this, or something that we already know, combining like terms. So it's reintroducing the idea of this. Very last, guys, this is going to bring us into our next vocab word as well. Write an expression to represent the sum of your answers from item 1, 2, and 4. So we're just going to go backwards here, writing these out. A sum, again, is addition. 5x squared plus 4x plus 16. A sum of the terms from items 1, 2, and 4. So again, on the next page is where we're going to get into the brand new vocab terms. So expressions like the answer to item 5 are called polynomials. A polynomial is a single term or the sum of 2 or more terms with whole number powers. Okay, so we have worked a little bit with powers that are exponents, but when we're writing polynomials, we are only going to use, or you will only be given, whole number exponents. So again, the terms, list the terms of the polynomial you wrote in item 5 is simply just writing out each term, but we're going to put a comma in between them. We're listing the terms. Again, this lesson is making sure that we have a full understanding of the vocabulary before moving into the rest of this unit. Now it's going to, again, throw us some words that we've used a lot before. It's asking what are the coefficients of the polynomial in item 5, and what is the constant term. So again, a coefficient is a number in front of the variable. So the coefficients that we have are going to be 5 and 4, whereas our constant term is the only term without a variable, is going to be 16. Again, coefficients and constant terms are not new, but again, we're going to be using them a lot more, so I want to make sure that we have full understanding here. Take a moment to review the check understanding problems, numbers 8 and 9. So it says, tell whether each expression is a polynomial. Again, look at the definition to make sure you understand what a polynomial is. And then for number 9, for the expressions in item 8 that are polynomials, identify the terms, coefficients, and constant terms. That is something that you could put towards the bottom of the side of your book in the math notes section. So again, go ahead and pause the video here and take a few minutes to answer questions 8 and 9. When you are finished going through this, tell whether each expression is a polynomial. For letter A, it is not because of the negative exponent. Again, as a review, whole number powers, well, whole number is 0, 1, 2, 3, and so on. There are no fractions and no decimals, no negatives. Letter B is a polynomial. C, even though it is a single term, is a polynomial. D is not because of the fraction. So identifying the terms for part 9, 6x is an entire term. If you remember, the definition of term is a number, variable, or product of a number and variable. So 6x is a product of a number and a variable, making it a whole term. 4x squared is a term. For letter B, the coefficients are 6 and 4, and there is no constant term. For letter C, the only term is 15. Since there is no variable, it is not a coefficient. It is a constant term. So now we're going to look at what does it mean to be the degree of a term. So we'll have two different definitions for degree. The first is going to be degree of a term. So the degree of a term is the sum of the exponents of the variables contained in the term. So this is pulling apart each different term and looking at, again, the sum of the exponents of the variables. So in the table, it pulls out the first term, 4x. Since there's only one exponent, its degree would be 5, and its coefficient is 4. From number 12, again, the only exponent is 3, and that is its degree. Again, we have an exponent of 2. Now be careful here, the coefficient is not 0. Whenever we have a term, there's the invisible 1. Because 1 times anything is itself. So 0 will never be a coefficient, because if it was, there would be no term. And for our final term here, x to the first power. Again, this is not 0 because x to the 0 power would be equal to 1. We clearly have an x, so x to the first power is x. So our degree would be 1, and our coefficient, much like the term before, would be -1. So again, notice how we do not pull out the 5 to identify it, because 5 does not have any variables in its term. So we would not identify a degree of 5, it is simply just 5. So for number 11 down here, you can make a table like the one above, or you can simply list the terms. Making a table is probably going to be the simplest way to go, but take a minute here to list each term and identify its degree and coefficient. So again, we're going to make a table, very much so like the one above, and list the degree of each term and the coefficient of each term. So pause the video and take a moment to fill out your table. So again, guys, as we're looking at creating a table here, one thing to keep in mind that is we are looking for the sum of the exponents of the variables. So if we're looking at the first term from number 11, we have 2x cubed y. If we're looking at the sum of the variables, we have to include all exponents. So for the first term, we actually have a degree of 4 with a coefficient of 2. Second term's a lot easier to pick out. We have 2 and 2 again. This is also a degree of 4 with a coefficient of -6. One thing that we need to remember is that a minus sign also means adding a negative. So whenever you see minus a term in a polynomial, its coefficient is technically a negative number. So that's something very important to remember as we continue going along. For the third term, x to the first, y to the first has a degree of 2 and a coefficient of 9. The fourth term has a degree of 5, a coefficient of -13, and our last one is a degree of 1, coefficient of 5. Again, we do not list 15 when we're trying to find the degree because it does not have a variable. So now we've listed all of the degrees and the coefficients of the terms. If we look at the top of the next page, we're going to figure out another definition of degree. If we're talking about the degree of a polynomial, we're looking at the greatest degree of any term in the polynomial. Now again, remember a degree of a term is the sum. So for the first polynomial, the highest degree is 2. And it's also looking for now a constant term. So again, we go back and forth between a lot of these vocabulary terms. For the second one, the highest degree is 3. A constant term, again, remember, -3. And the third line is kind of backwards from the rest of the problems that we have seen, but the same principles apply. This is the largest degree of 2 with a constant term of 36. Okay, so make sure that we're staying with me here because we're about to introduce about 6 more vocabulary terms on this page alone. Now we're going to be looking at standard form of a polynomial. Just like we have different forms of equations, we have a standard form of a polynomial. It's a polynomial whose terms are written in descending order of degree. The leading coefficient is a coefficient of a polynomial's leading term when the polynomial is written in standard form. So below you'll see actually a really good example here, guys, of all of the vocabulary that we have learned up to this point. As you'll notice, this is all set up going from least to greatest in terms or degrees of the terms. The largest degree is going to be set first. It's called the leading term. So the leading coefficient is again the coefficient that goes with the term that is first. And our constant is again the variable at the end. Now, because this is going in descending order, I want to make sure that we understand a constant can technically be written with x to the 0 power. Because again, anything to the 0 power is 1, which leaves us just as -3. So a constant at the end is at the end, 1 because there is no variable, but 2 because the understood variable is x to the 0 power, which would come last. Now, the next 3 words that we're going to look at are terms to describe a polynomial. So a monomial. Monos meaning 1. One term could be 8, could be 2x, could be 3x squared. As long as it is one single term, we call that a monomial. A binomial is 3x plus 2. If you remember from a few weeks ago when we were practicing IXL, I very quickly taught you guys the FOIL method. FOIL method deals with multiplying binomials because now we have 1, 2 terms. And then of course we have trinomial. Trinomials are what we will be dealing with the most. It is the most common form of a polynomial in algebra, right after a binomial. If anything is greater than 3 terms, we simply call it a polynomial. We do not have a quadnomial. We do not have a hexanomial for 6. We just simply say polynomial if it has greater than 4 terms. Okay? So if you look at the reading at math, it kind of gives you a description of why we would use mono, bi, and tri. And in poly, I did not know this until last year when I taught this lesson. Poly is actually a term for many. Okay? Bisect, cut in half into 2. Triangle, a 3-sided figure. And polygon, which is the other place we see the word poly a lot, is just a many-sided figure. Okay, we're going to go ahead and turn the page, and at the top of the next page you again see a very, very large table. This is going to put all of our vocab terms together into one table just to practice what these all look like and what they mean. So the first one, it's giving us a polynomial, asking for the number of terms. I see 1, 2 terms, so the name would be binomial. We would call this a binomial. Its leading coefficient is the first number that is listed, which would be 3. This does not have a constant term. But again, we could always list 0 because you can always add in a 0 and it doesn't change the function. And this has a degree. Again, this is a degree of a polynomial. So degree of the polynomial. And the degree of the polynomial is the largest degree of a term, which in this case is 2. Now, as you continue to fill out the table yourself, again, pause the video, fill out the table, and raise your hand because the sub will come around and check your work. So raise your hand for the sub to check your work before you move on to the check your understanding. So again, once the sub checks your work, they will give you a bag of algebra tiles, so you need to complete the entire table before you can move on to the next lesson.